So we are honored to have our next speaker, our next speaker is Mr. Nico Vandepoele. I don't know I'm pronouncing correctly or not. And he is a Scientific and Professional Affairs Manager of Analyte Laboratories Quality Control Division in US. And I have heard Mr. Nico's talk many times, and he is one of the great orators, and he serves as the Scientific and Professional Affairs Manager for the Analyte Laboratories Quality Control Division. He works to promote an understanding of the laboratory regulations and best practices as they pertain to QC and EQA or PT programs. Nico is well-recognized speaker, a very good orator, and he presents trainings, workshops, lectures at symposia around the world, and volunteers on several CLSI committees. So he is in several CLSI committees. And he studied dual degree in information technology, chemistry, and he worked in clinical lab and for then biotech company as head of the research lab before starting as Biorad field application specialist. And in 2010, he became product manager for quality system division in California, and where he managed the Unity and EQUAS informatics programs. So many of us are very much dependent on Unity real-time and EQUAS informatics programs. So he is the man behind this program. So we are really very privileged to have you for your talk on troubleshooting with inter-laboratory comparison programs. Nico, please.
Thank you very much, Dr. Barnali, for that kind introduction. Welcome, everybody. Good evening. It's early morning here in US, so let me start by sharing my screen. So thank you again. So I wanted to thank the organizing committee for giving me the time to talk to you a bit today, and to say that I joined already for a bit of time, and I really liked the previous presentations. And I also liked how they all tie together and talk about the quality of the tests. And so for this last presentation, I wanted to talk to you a little bit about interlaboratory comparison programs and how we can use them to troubleshoot in the lab and what the differences are. So as just a couple of quick objectives, let's just look at a little bit of the differences between interlaboratory comparison programs. And then I'll take a look at the proficiency testing and show how we can have a couple of steps for troubleshooting. And also then look at a different interlab comparison program, which is your daily QC quality control interlab. And so show also how the performance indicators of that program can help you to do some additional troubleshooting. So let's just start with a quick overview of these programs. And it's really simple to start talking about it. And that's what is an interlab program. And as soon as you compare samples by more than one lab and you collect the results and you compare it, you're doing an interlab comparison. You're going to hear other things, for example, like you could say split samples. If you take a sample, split it in 5 and send it to other hospitals, that is already a small interlab program. And I think we even heard that as being one of the challenges of the pandemic, that if you could not get the products to your lab, that maybe within your city, one lab can take the initiative to take a sample, split it, and send it to other labs, and so they can compare within the lab. So that was a nice example of how a small interlab comparison can already help you with your quality system and can already help you to provide valuable results of comparison between the labs. And so the most commonly known proficiency or the interlab comparison is a proficiency test or external quality control. And there's many names. So there's EQA, EQC, proficiency test, PT. But as soon as you get a blind sample that is sent to the lab, and then you send back your results, that is what we would call interlab comparison proficiency testing. Most of these are known because we have them by regulatory organizations, and they are most of the time mandatory. But what also is a difference is that they're very different country by country or region by region in the world. And there's also, of course, commercial companies like BIRAT, for example, that also organize proficiency testing or external quality control. And those are then more of an educational nature and less of a regulatory or less of a punishable program, you would say, because for some proficiency test programs, failures could have big effects. If you have multiple failures, you could actually have possibilities that they come and check your lab, or they even shut down your lab. So a second interlab comparison program is based on your daily quality control and is provided by your quality control material provider. And so also their BIRAT has a program. So what you do there is by running your daily quality controls over and over every day, you monitor your precision. And then what happens is that once a month or on demand when you want it, you can send that data to your provider. Your provider collects all that data, groups it together with the correct peer grouping, and then sends you that data back. And that is a second kind of interlab comparison, which is different from the first one. And I'm going to try to show you what the differences are and what some of the advantages or disadvantages could be of the two programs and how you can also troubleshoot with them. So it is important to understand that there's many differences between all these proficiency test programs, and there's international standards and guidelines, but it is important to always know that what I am talking about here might not be always exactly the same as your program in your lab, because it could be offered by a different company or by a different provider. And so it is always important to understand the principles of the program, and then you can understand why some of that troubleshooting might be going in one direction or why we might be looking at other things for another program. So this is what I'm trying to help you with today. So, and I liked how I have already seen some of these examples, but I always want to start by explaining the purpose of the interlab comparison, but also the definitions. And so you always see that normal distribution, as you can see it here on the slide. And that normal distribution is when we run a sample over and over, unfortunately, we don't get the same result every time. That would be the great solution. If every time we would have exactly the same result, we wouldn't even be talking about these things, but we all know this doesn't happen. So you get a result a little higher, a little lower. And when you put all these results together, if you would measure hundreds of them, you get this normal distribution. In the middle of the normal distribution is our mean. And the size of this distribution is our precision or standard deviation or CV, or the expression of a random error. Nothing is really wrong with the system, but due to little fluctuations in temperature, volume that we aspirate, reagent consistency, all these things give us slightly different results. And this is what we monitor with our internal QC, with our daily QC, we measure the precision. Well, now the next step is to know the true value. And so this green line here is our true value. I've put this true value far away from our distribution. Ideally, where do we want to see this true value? Of course, exactly on that dotted line, because that would mean that we have the correct true value measured. But just here to explain the definitions, the true value is a little bit further. For proficiency testing, for example, too, the true value can be defined in different ways. And that is part, for example, of an ISO 17043. There are different ways that you can evaluate or give a true value to a sample. You could do that with reference methods. It could be reference material. You could do it by expert labs. But most of the time, and when we're going to talk here as example with BIRAT programs, most of the time, when an interlab program is used, we're going to look at the peer group mean, or we're going to look at the results of the labs that participate. And that is what we take as our target. And that is what we use to calculate our true value. And so then when we compare the mean of our population with the true value, we're actually estimating the bias, which is the systematic error. And this is called the trueness. And this is what you would do with, for example, the Unity program or your daily QC program. And the difference with a proficiency test program is with the proficiency test program, you see here that with the X, with the red line, you measure one result. When you measure one result, you're always somewhere in that distribution of your results. So you all know that if you measure your proficiency test 2 or 3 times, which by the way, you shouldn't do, proficiency tests should always be run just once, because that is exactly the same as we do with our patient samples. We just run them once. But if you run your proficiency test once, you are somewhere in that distribution. And so the difference between your one result and that true value is what we call accuracy. And so that is a little bit different. That is proficiency testing. That is a little bit different than a trueness. But to be really honest, accuracy and trueness are almost always used mixed up with each other. And a lot of people, when they talk about accuracy, they will never even talk about trueness. But if you look at the official definitions, the difference between an accuracy and a trueness measurement is that an accuracy measurement is one measurement, and a trueness measurement is the average of as many measurements as possible. And so that is the difference. A proficiency test is just the one result. And when you look at a daily QC Interlab program, you actually compare your mean to a population, which is a difference because that mean value is a closer expression of what your target really is that you measure. So it would almost be, and I don't like to say it because I'm confusing things then, but the more you would measure a result, the more you get closer to a trueness estimation than an accuracy estimation. So what are these benefits of looking at interlab comparisons? Well, we want to detect and identify potential analytical errors. So especially when we change reagent or calibrator lots, when there's standardization adjustments, the manufacturer has a new reference material that they're using, these changes can all have an effect on our results. And so when we are measuring either proficiency testing or daily QC, and we compare that to our peer groups or method groups, we can see if changes are going on. We can also identify trends and shifts that may occur between proficiency tests. Because if you as a lab, you would rely only on proficiency testing to show you when there is actually a difference between your target and your measured results, then it might take you a long time, depending on the frequency of your proficiency testing. If it's once a month, it's already 12 times a year. But there's also programs which only offer you proficiency testing once every 3 months, or maybe even just twice a year. So if you only get an estimate twice a year of how well you're performing compared to your peer groups, that might be very far apart, and it might be limited in information. So when you're also using a daily QC program that compares your results every month or whenever you would like to see it, that can give you another way of identifying these trends and shifts. Also, when you're starting new lots, for example, in a daily QC program, if you compare yourself to the peer group, that can give you another sense of confidence, another feeling of confidence that you're doing really well compared to that group. And of course, in the end, we're all doing this to improve the reliability of our test results for our quality patient care. So we also do this because we have to. We also need to have accreditation and regulatory requirements, and we want to demonstrate our commitment to our quality and help to meet the ISO 15189 or other NABL accreditation requirements, for example. And so also to implement and maintain Lean and Six Sigma processes, that means that we need comparisons, we need our CVs, we need our biases to calculate Sigma metrics, for example. And how do we do that? Well, participating in an interlab program is one of the easiest ways to get all that information. You could also start purchasing reference material, for example, to calculate your biases. But as you know, those materials are a lot more expensive. And so if you already have your QC material available in the lab, just adding the information to an interlab comparison can give you a lot of that additional value. Just a couple of the clauses here for ISO. The lab shall participate in an interlab comparison program. And if you do, it should be one that fulfills the requirement of ISO 17043, So again, this is just a standard, the ISO 17043, and you know that if your proficiency test provider is accredited to 17043, you know that they're going to be doing the right steps to give you valuable information. And there's a little note also in the standard that if you would not be able to find a proficiency test program, you shall develop other approaches. And one of the examples in there is control materials that are tested daily in an interlaboratory comparison program. So that is exactly what we're talking about, using your daily QC, send that into your provider, and when they compare it, that can give you a good alternative for proficiency testing if it's not available, or just an additional evaluation. So you have a way of troubleshooting, sometimes one or the other with each other. So that's also additional information. It's important to get a trusted, unbiased perspective. And that's why you're using independent controls and independent proficiency test programs. They are not optimized for a specific test system. If you would just be running a manufacturer control, they could often be based on the calibrator material, and that might be something which could hide specific effects or specific errors that you might not see because they're the same material and they have the same degradation rate or they have a same error built in, so you would not see that. So that independence is important. And of course, try to be part of a very big group of data users. If you're comparing yourself with one or two other labs, that's a start, but it could be hiding some specific bigger distribution issues. Like, for example, if you compare yourself with everybody in one city, you might all have had the same lot of reagents from the manufacturer. If you compare yourself to a whole country or worldwide, there will be different lots of reagents and different shipments going on. And that might show you that there was a problem, for example. And of course, it also helps you if you work with a daily QC program. It gives you information both on assayed and unassayed control materials. So even when you don't have insert value ranges to guide you when you start with controls, your peer groups are very valuable evaluation programs. And then also the official proficiency test programs can be supplemented. I already talked about that a little bit. So complement your official programs by doing an educational additional program and compare to peer groups, or also participate with your daily QC into a peer group. That increases your confidence that your regulatory proficiency test will compare well if you're already doing well in your daily QC comparison and in your commercial proficiency testing, for example. That could already be advisable. And then daily QC interlaboratory programs, again, some of the parameters that are not available in a proficiency test program, they could be run in your daily QC program. And it also reduces the proficiency test for duplicate instruments. That's sometimes a question I get. When you have multiple instruments in the lab, some labs tend to run their proficiency testing on all of them, or some would circulate it between the different instruments, because that is like a patient sample too. But often you could say, compare your proficiency testing to a patient sample. When it comes in, you run it once. Your daily QC is the program that should align your instruments to each other. And then you should just run one proficiency testing, and you wouldn't need to run proficiency testing on all your instruments, for example. So that's just something additional with your daily QC and your proficiency testing. You can compare each of your instruments. They're all part of that program. And just as a visual example, so this is just here an example. On the top, you see in purple the proficiency test program, EQUAS, and then below you see your daily QC or your Unity with your Levi-Jennings chart. And I like this comparison, how somebody said that your proficiency test is like taking a picture, and it's almost like an older camera and not the digital one anymore. But when you take your picture, you normally had to send in your film, and it took a couple of days before you got the pictures back, and then you knew when they were doing well. Well, that is what still proficiency testing is, because when we run the sample, we send in the results, but it can take a couple of days before we know the results. If you look at your daily QC, that is the new cameras, or that's a movie, you actually, as soon as you take you get your result, you know immediately if you're doing well, yes or no. So that's also a little bit the difference between the two programs. It's a real-time monitoring of your QC, while the other one is more a snapshot or a picture taking in time and can take a little longer to see it. So here, for example, you can see that my Levi Jennings had some problems in Q2, and that was also picked up on by the proficiency testing. But of course, that takes a little longer, and ideally that should have already been caught by your daily QC so that your proficiency testing would not be affected. And this is just a summary of the two programs again. So proficiency testing on the left, daily QC program on the right, accuracy measurement, blind samples, proficiency testing, and then you have a trueness assessment by recording a mean of points from your Levi Jennings, and that's more of a systematic error assessment through bias calculation, and that's more of your daily QC program. So regulatory ISO 15189 requires proficiency testing for sure. And then the other program is available as an additional standard, as an additional tool for your standard, which gives you a lot of additional information for your sigma metrics. We talked about method validation. Also here, these results can help you when you're changing from one method to another method. You can actually look at the peer groups and see how much these peer groups differ. That can also help you there. So let's take a look at how we can troubleshoot with our proficiency testing. And like I already said in the beginning, different programs have different ways of evaluating. So there are standards for the statistical methods. And so again, it's really important to look at your proficiency test program and what they use exactly. But most of the time you will see something which they call the Z-score. And the Z-score is your result minus the comparator target or the mean divided by the comparator. And that gives you an expression of how much standard deviation you are away from the target. So the ideal value is 0, then you are on the target. And most of the time, the regulated programs will say when you're outside of 3 or -3 Z-score, you're going to get a red flag or a rejection flag. Some other programs might already start warning you if you're between 2 and 3 or -2 and 3. And that's like a kind of a 2 standard deviation warning that you would get. And as you will see when we troubleshoot a bit more, I would say one of these warnings could still be something that you monitor. If you get multiple of these yellow warnings, that would mean that it's also something you have to take action on and start troubleshooting. So when I talked about comparators, it is important to understand what the comparators are in your different programs. And the most important one is, like we always talk about, the peer comparison. That's the ideal comparator, same analyte, instrument, method, reagent. Units are normally converted, so you don't have to worry about that. But that is what you ideally compare to, because then you're looking at exactly the same system, and it should be exactly the same results that you should be getting. But if that group is not big enough, or you're the only one in that group, you have an instrument that's not very popular in your region, or you have a specific reagent that's new in the market, you might not have a good peer comparison, and then you need to go to a method comparison. And this is the comparator group that goes across instruments and across reagents, but looks at the same analyte and method. And then the last one, if you go lower, is the all results comparison. So that just looks at all the results for the analyte. That is always the group you have to be a little careful with. Some programs, like for example, also the Bio-Rad EQUAS program, will break this group up even in different modes, because sometimes there can be really big differences. I just think top of my head, like a lactate dehydrogenase, LDH. If you have a pyruvate to lactate or a lactate to pyruvate method, results can almost be double the difference. A result of 200 can be 400 in the other method. Well, if you put all those results together in all results, you get a mean somewhere in the middle and a very wide distribution, and your comparison isn't that valuable anymore. So that is why some programs would then like break up these all results into modes and keep each mode separate so that you get a better valuable comparison. It is also always very important too, when you look at an evaluation of an interlab comparison, to look at that imprecision of that group. If you see that the group imprecision is very, very wide, you might understand that it's very easy to pass and to be compared to it and have a good result. But make sure that you understand what the value is of that group, because sometimes these groups might be so wide that there's actually almost no comparison anymore. So this is just an example, and I won't go too much in detail, but what you would see most of the time in different reports is a part with your statistical analysis. Your results are there, how many participants were there, what is the mean, the standard deviation CV, what is the uncertainty of the group. Be careful. Uncertainty is normally a mandatory result that should be provided by a proficiency test provider, but this is the uncertainty of the peer group. This is not your lab's uncertainty. So this just tells you how reliable the mean of that lab, of that peer group is, okay? Often you will also get histograms, which show you the distribution of the results. Like in this program here, you can see the different distribution of the peer, the method, and the all results group. And then you get Z-score trend charts. They are almost like Levi-Jennings, but the difference is they are not your daily QC, but they are actually each of your proficiency test results, one after the other. And then part D here is just most reported instruments. If you want to look at other instruments results and see how different they would be, you could see that in here. This, for example, is a glucose report. And as we already heard from the previous speaker, glucose is very well standardized. So if you would go through this list here of the most reported instruments, you would see that for this very high glucose of 600 milligrams per deciliter, almost everybody finds this result very comparable. It goes from a 627 to a 590, which is very well standardized. There are, of course, many other tests that don't have such a good standardization, and you would see that here in that distribution. Also, as a little comment, when we look at those trend charts, the top one is just the chronological results one after the other, and the bottom one is something specific here that is your Z-score trend chart based on the concentration. And that can actually be very valuable and give you additional information. And I've put a couple of examples in here where, for example, just to start with this one, on the top one, you see all our results throughout the year, and they are very close to our target. They're all within -1 and 1 Z-score. So this is a perfect report. And as we see in the bottom, over all the different concentrations, very well reporting. But this is something where if we would just look at this top Z-score trend chart, you would see that I have a couple of results which are in the gray zone between 2 and 3. So they're a little bit of a warning. And there is one at the end of the year, which was outside of the chart, which was a rejection. But when I look at this top chart, I wouldn't really see anything special than just some variation. But when I now look at the bottom chart, I can see that every time I had a very low challenging result in my proficiency testing, my results were high compared to the peer. And when I had a high one, my results were low. So you can see here that there was a linearity problem where I'm doing really well over the normal range of the assay, but in the low and the high range, I might have a problem. And this is something where proficiency testing with challenging targets can help you more than your daily QC, because your daily QC will probably be concentrations closer to these middle values, because normally you wouldn't be looking at such extreme values when you do your daily QC. And here, for example, is a lab that started off, and in January and February and March, they had results that were a little low. And so after these 3 or 4 warnings they were getting, they started to take action. And then you can see that from then on, they fixed whatever problem they had, and all the results were nice on target again. So as a proficiency test provider, we also have a kind of troubleshooting chart that we can provide to help the labs. But to be honest, each lab should establish their own troubleshooting map and their own troubleshooting guidance, because for each lab, there's little different circumstances that can be affected. So this is just a general one to start. And to be honest, this top one and the ones I've put in here is almost more like the general practice of checking if everything was okay. So here, for example, it says that, okay, well, do you have a flag, a warning yellow or a red rejection? Well, the first thing to check is the result that I reported actually the same result as I measured on the instrument. because a lot of the errors we still see in proficiency testing are clerical errors where people just they miss a decimal place, or they just mixed up two tests and they reported the glucose result for another test and the other test for glucose. So that is the first thing that you have to do. And if it's wrong, there's nothing bad in just changing your result and sending it back in, just monitoring and documenting that you made a mistake there. After you made sure it's the right result, also make sure that you have the right configuration. Because sometimes people change an instrument or change a reagent, but they forget to report it to their proficiency test provider. And so now you're compared to the wrong peer group. So again, if you're reporting to the wrong peer group, there's no value in doing that. So correct that and make sure you get your reports back with the correct comparator. When you start looking then more detailed at your sample, one of the things, for example, is there just one analyte that has a problem, or do all of them have a problem? If all of your analytes have a problem, like see here this example on the right, how sample 9 and 10 were pretty good, and then sample 11, everything is bad. Well, if everything is bad in your sample, start thinking about some systematical thing. Like here, for example, the lab just mixed up two samples. They reported sample 12 instead of sample 11. And there's no need to go troubleshoot each of these analytes and go look at it. No, you did something wrong with the sample. Go take the right sample, run that again, and send us the new results. This could also be something due to reconstitution of the sample. I've heard examples where people, by mistake, took the wrong liquid and put some alcohol, for example, in the sample. Well, your sample will be degraded and you will not be able to run the sample anymore. People reconstituted with tap water. That could also affect some of them. People had a pipette that wasn't well calibrated or had an error. And so the value, the liquid they added was way too much. So now all the results are low. So you would see all of your results that are affected. So these are all the steps you can take when you see these different events going on. When you then finally go to one analyte, then go and take a look. If it's a rejection more than 3 or minus 3 z-score, start troubleshooting right away. If it's a warning, then you can check, was it the first time I get a warning? Then you could continue. If I have seen previous samples flagged already, then start troubleshooting again if you get multiple warnings, a little bit like the example I showed you. There's also other documents with more detailed troubleshooting. Again, like I said, you can use this as a guidance to start with, but it might be important that you update this with specific steps that are available in your lab. But here, for example, it starts from, okay, was the kit received in a good condition? If your proficiency test samples arrived, but your kit was not frozen anymore or was warm, or the box was damaged, those are things that you should note, because sometimes you might not see it in the first or the second sample, but maybe after half a year, you start seeing things like that. And that might be due to that shipment, for example. Sample preparation is also very important. Document who does the reconstitution, who's handling the sample, which pipette were they using, was this pipette calibrated, when was the last time they calibrated, which kind of deionized water did they use. All these things might be important. And remember that sometimes when you get your results back a week or later, after you run the sample, most people won't know anymore what was done at that time. So it could be important to document those things while you're running your proficiency test sample. When you have a failure, go look at your daily QC. Was everything good there, or were you already seeing shifts? What was the last calibration? Did something change with the reagents? Was there a reagent problem? Or was there maintenance done on the instrument? All different steps that you can use to document and see if something systematical was going on, or if this failure that you had was just a random error, because they also still do happen. I think in some of the studies, it showed that up to, I think it was up to 40 or 50% of an error of proficiency testing cannot be traced back to a systematical error, but is sometimes just a random event. When that happens, you can also see if you still have the sample and you can use it again, you could retest that sample. Be careful, always check your insert of your material. because some samples, like for example, like blood gas samples, you are not able to store these until you get the results back. A blood gas sample, you have to open them, run them right away, and then you have to discard of that sample because 2 or 3 hours later, these results will not be the same anymore. For some other chemistry or immunoassay, if you still have some sample left, you could store that. And you could, if a result comes back, you could always see if you can repeat it once to see if it would still occur or not. Also, the last one is important. Like I already said, look at your peer group comparison. It can happen with very low results, for example, low magnesium, low potassium. We have seen that a very precise method, let's say all the labs find 2.1 for a potassium, and you're the only lab that finds 2.2. Well, statistically, you're going to be flagged as a very high outlier because there's almost going to be no standard deviation because everybody's on that very low target. But there's actually a second report that you can use to troubleshoot and to almost like explain your failure. And that is what we call here a quality specification report, where you're not looking at the statistical evaluation of your results, but here you can use a biological variation or a regulatory target, for example, a CLIA limit, or for example, an RCPA limit to evaluate your result. Because some of those regulatory bodies also have evaluation targets based on specific analytes. So most of the time, proficiency testing evaluation on interlabs are going to be based on the distribution of the systems. But some regulatory bodies make their own limits based on biological variation or based on their own regulatory guidance. And they might say, well, we say if you're 10% difference, if you have a result which is within 10% of the target, we think that's acceptable. Your peer group could be a very precise method and could say that 5% is the limit of the instruments. And so you could get flagged that you're outside of that 5%, but you could still be within the 10% of the official guidance. And this is a second report that does just that. It compares you to either, like I said, biological variation, RCPA, really bad. There's different guidance there. If you have a local guidance and you would like to use that, you can always reach out to Bio-Rad and we can add that evaluation even in your report. And so this was proficiency testing. So we've seen that a lot and we've used that a lot. So the second part is when we look at interlab comparisons when you're doing daily QC. And just as a quick summary, you run your QC on your instrument, your results go to your data management system, like a Unity Real-Time from Bio-Rad, but that can also be your LIS or your middleware. You do your daily QC, your Westguard rules, your Levi Jennings. But then the advantage you have with a Bio-Rad program, for example, is that you can then transmit that data from your Unity Real-Time and participate in the interlab program, where through QCNet or through your software, you can actually get a monthly summary report, or you can go, and that's called Instant QC, go and get a report whenever you want it, or look at your data even in your Unity Real-Time at your peer group data and compare yourself. So this is a second way of doing peer group evaluation. And when you participate in such a group, you have two performance indicators. You have a standard deviation index, and it is your mean minus the consensus group mean divided by the consensus group SD. And you can say now, Nico, well, that's the same thing you just showed me about Z-score, and you are right. A standard deviation index is the same formula as a Z-score, but the difference is that a Z-score is one result. It says your result, while a standard deviation index says your mean. So it is the mean of all your results that is compared to the peer. That's a standard deviation index, and a Z-score is just one result. The second comparator is the coefficient of variation ratio, the CVR, which is just comparing your CV to the consensus group CV. And this is something which is important because a daily interlab program, a daily QC interlab program, can look at CVs of methods, which is something that proficiency test programs cannot, because they only get one result. They can't really see the imprecision of the method. A daily interlab program here, like the Unity program, now what you can see is you see two histograms here. On the left side, you see a distribution of the results of the peer group. So these are all the means of the labs participating. And on the right side, you can see the distribution of the CVs, of the variation of the interlab participants. And so what you can see here with the little arrow in the bottom is that on the left side, the lab is doing really well, is almost in the middle of that distribution of the results. And on the right side, you can see that the lab is a little bit on the higher side for the imprecision. So their CV is a little bit high compared to what everybody else runs as a CV on their instrument. So this could be an indication for the lab to maybe check up on maintenance or see if there is anything in the variation. For example, are they really treating the QC correctly? Are they not leaving it out too long every day and they have a nice procedure? Because I always repeat that too. It's very important. The way you treat your QC every day also has an effect on your variation. If your technicians take out the control and leave it on the table for several hours every day and then just put it back in the fridge in the evening, that can actually create higher CVs because of the temperature shocks and variations of that QC than somebody that just takes out the QC, lets it get to room temperature, takes the sample and then puts the QC back in the fridge. Even in the fridge, you can store it in the door of the fridge, but that will, for example, get a lot of temperature shocks when you open and close the door. A lot of time, what you would do is you put your QC in a box and that box goes in the back of the fridge, or ideally even in a fridge that doesn't open 100 times a day, for example. So those are all little things that you can see in this variation charts and this histogram distribution of CVs. You also get nice summary reports every month here. And in here, the advantage is that you get not just your target, your mean, but you also get a CV or an SD evaluation. And there's actually another report which is called the bias and precision histogram, where you can actually see those two vary. This is just your target. And here, for example, you can see that around December or January, something happened in this lab. And before, they were always a little bit below the peer group. And then after, they were a little bit above it. They're still acceptable. They're still within the limits. But it clearly shows that in the middle of that and the transitioning of the year, December to January, that something happened here. Did they change a reagent lot? Did they have maintenance? Did they start a new calibrator lot or something? These are things that you could then investigate and see that difference a little bit in results. I also have a little case study in here to finish this presentation. This was a triglyceride issue reported to the Unity program by a lab. And so what happened is the lab called us and said, well, I'm getting a rejection today. And I've never had that. Previous months, I was always fine. So what you can see here is if your result is too different from a peer group, you're actually going to be rejected because the peer group is statistically protected. Because if we would allow all the results to be accepted, that peer group value is going to go down. So you can see here that the lab had a warning for level 2. They were more than 2 SDI away. And by the way, for the BIRAT program, for your daily QC, we warn you already at 2 standard deviation, or like a 95% confidence, because you're sending us a mean of results. Like remember in the beginning of the presentation, that distribution, when you're reporting a mean, that is way less prone to variation of your imprecision because it's a mean. So here we're already flagging you at 2 standard deviation index. So the lab said, okay, what happened? So we helped and troubleshooted with the lab. And what the lab noticed is that after they got the rejection, they actually saw that they had changed a reagent lot a while ago, like about a month ago. And the results were a lot lower. So you can see here that when they were looking at their chart, they saw that they were below the target in their Levi Jennings. And so after they got a failure from the Unity report, they recalibrated, which is in the red circle, and the results went back to the target. So that is an example of like, okay, well, we were low and rejected. So now we were corrected. We had a corrective action and we fixed this. But there was more than just having this corrective action, because as you notice, the results were all still acceptable in this Levi Jennings. So what happened is that the lab noticed that their fixed standard deviation was quite wide. And that was why they didn't pick up on the problem when they changed their reagent lot. Their results dropped, but they were still within the limits of their Levi Jennings of their daily QC. So they just kept going. But then when they compare themselves to the peer said like, hey, you've dropped quite a lot and we want to flag you that there is something going on. So the lab calibrated and fixed the issue, but now they should also take a preventive action. And the preventive action is that they updated their fixed standard deviations to make them narrower so that next time when a reagent lot would change, they wouldn't drop out of that limit. So out of the peer group comparison, they would notice that in their liver Jennings right away. And so they wouldn't be low for that month. So this is a part where I can show you here with this example, how a lab can both fix the problem, but also prevent a problem by troubleshooting this value. And so as a summary for this presentation about interlab comparison programs, just want to show you again. So it's an assessment of the performance of your system, analytical quality of the system, reliability of the reported results. It also helps you to look at the training of your personnel, because again, if you would do proficiency testing and you let one person run the sample, you might pick up on slight differences of somebody's performance. It is an accreditation requirement for ISO 15189 and many other regulatory bodies. So it provides quality for your lab. It is also something that can look at harmonization, because if you go to an interlab comparison and you look at all the different results like we did for that glucose is very well standardized. But if you're going to go to an LDH or some other tests like immunoassays or even serology, you're going to see that some of these results can be very different because there is no international standard available, or because different manufacturers have used different targets. And so they have a variation. So that is also something which you could clearly see in proficiency in interlab programs. And additionally, I hope with a couple of examples I show to you that they're an additional tool to help you find issues that are going on with your test system. And it can help you to correct the system and prevent these things from happening in the future. Thank you very much.
Thank you. Thank you, and Nico, for excellent presentation. One of my query in this, and also there are several questions in this topic. One query is like for the rare parameters, sometimes we don't have the like PT program or ECOA program. So for those samples, suppose some neuroimmune markers or something like that. So how many samples we should do for interlab comparison with another lab? And for those samples, what we should we do, calculate the critical difference and verify? Should we follow for that also the CLSI EP26A, or if you can share your insights? Yes.
So there's some of those. I know the EP26.
For lot-to-lot verification, but
that's the lot-to-lot verification. But I know the GP27 is proficiency test, because I actually was on that committee, and it gives you guides that you can do split sampling, but there's no real document that I think that has specific guidance on split samples. It is a little bit like you said, you have to decide, because if you're only doing 1 or 2 samples, like I already said, it might not be that valuable to say we're going to calculate a mean and a standard deviation of the 3 labs and see if we're in there. There you might say like, okay, we're going to say that this target, we're going to take 10% or a total allowable error that you would use a regulatory one, and see if you're within that limit. You have to look, of course, a little bit at who's running the samples. Is there one hospital or one lab that participates that has a reference method? Then you would look a little bit more to their target as being your true value. If there is no reference value, it's a problem, because you don't really know which lab might be sending you the right value. Even the lab organizing it might have a method which has a bias or has some issue going on. So it is a little trickier if you make your own program to figure out, okay, how many labs do I need? Most of the time for statistical value, we talk about like 10 data points in a peer before you have a good statistical value, 9 to 10. But I can understand that maybe sometimes you only have 4 or 5 labs that can participate with a new analyte that is really rare. So if there is a reference lab or somebody that's more an expert on that analyte, maybe you can check with them if they have a reference method and they can actually assign a value and then send it out to the other labs so you can see what that reference value is. If it's really new and there is no real reference or no real target, it's pretty difficult to find a true value. We could do a whole presentation on the true value of the analyte, of course.
Thank you. Thank you for your valuable insights and excellent presentation.